Hi, my name is Aubrie Easterly, and I am a teacher at Galvez Middle School in Ascension Parish. I am most passionate about making a positive impact on society by instilling my students with meaningful skills that they can apply both inside and outside of my classroom. My goal is to help students develop tools that will serve them not only academically, but throughout the rest of their lives outside of an educational setting. These include thinking skills, perseverance, and self driven learning habits. In this video, you'll see a group of 8th grade math students, including 3 English learners and 4 504 students, working through a lesson guided by Eureka Math Squared. Students engage with the lesson objectives by graphing a system of equations and identifying that their intersection point is known as the solution to the system. Prior to the lesson, students learned how to interpret and graph an equation on a coordinate plane. They demonstrated mastery of the concept that a solution to an equation is a coordinate that satisfies the equation. During this lesson, I focused on being clear and concise while intentionally developing the concept of a system by asking guiding questions and building on students' prior knowledge. While the camera doesn't capture it, students engaged in high quality mathematical conversations as they worked collaboratively. It was inspiring to see how much students are able to support one another's learning. And I wish it could have been seen through the camera, but regardless, I hope you enjoy the video. All right, day 1, module 5, new chances, new opportunities. But I'm very excited because it's going to be a pretty smooth transition from what we just got doing. You guys just proved to me that you guys know how to identify slope and identify the y-intercept. Everybody in here did a fantastic job with the fluency. And you guys told me how to graph those equations. Y'all are going to do great with this. I'm really excited. Our new module, systems of linear equations. Somebody tell me, what do they know about linear equations? Is that a new word for us? No, that sounds very familiar. Give me something. But what about this word systems? What do we think systems means? Any ideas? We are a system. A system is a collection. A system is a collection. So systems of linear equations. Moving on to module 5, do you think we're just going to be looking at one equation? No, we're going to be looking at a system. We're going to be looking at a collection of equations. Can I have somebody read the first bullet for me? Who is brave enough to read the first bullet? Thank you, Jacob, please.
A system of linear equations is a set of 2 or more that have to be solved at the same time.
Perfect. A system of linear equations is a set of 2 or more linear equations that have to be solved at the same time. Your keywords here are 2 or more linear equations, and at the same time. These equations are happening at the same time. When we graph a line, what do we graph it on? What do we call that? What do we call this? This is where we graph a line, right? What is this called? A graph, a coordinate plane. So now we are going to have 2 or more. We're going to have 2 or more lines on one coordinate plane. What about my second bullet? Who can read the second one? A solution, yes. A solution to a system is an ordered pair that satisfies both equations. If I have 2 straight lines, how many times will they intersect each other? Well,
said two straight lines.
This is a straight line. This is a straight line. How many times do they intersect right here? One time. All right, follow along with me. You should have two different colors on in front of you. Pick up your favorite color out of the two. We're going to use that color. What color should I use? Pink. All right, use your favorite color. That's going to be the color you draw the first equation. Y equals negative 3x minus 3. What is the first point I have to plot? Yeah. My y-intercept, which is negative 3. I'm going to plot it right there. But that's only one point. Edwin, how do I know where my other point is supposed to be at? What do I use to tell me? My slope. What is my slope? Negative 3. Very good. That negative slope is telling me what kind of line is about to be formed. A falling line. I can go up 3. 1, 2, 3. Am I going to go left or right 1?
No.
Good. Once you draw those lines, once you line it up with your ruler, draw a straight line through it. Perfect. Kylie has already circled the intersection point, which is exactly what I want you to do. What is the intersection point called again? The solution. The intersection point of our two equations is the solution. -1, -1. And what do I need around these two numbers? Parentheses. This is a point. I have to enclose it inside of parentheses. Remember, your first number represents what? X or Y? X. And then my second number is my Y. Good. I get to say that the solution to this system is -1, -1. What is holding these two equations together? Y'all see that? Is it showing up on y'all's paper? It's kind of light. This is called a bracket. It holds our system together. Our system contains equations. We're only going to be looking at systems that have two equations. Sometimes you have more than two equations. We're only going to have two equations that make up our system. And this is our what again? One more time? Our solution to our system. And then from that point, how am I going to draw the rest of my line, Luis? Luis R? How am I going to draw the rest of this line? I only have one point plotted. I know it's my y-intercept. How am I going to draw the rest of this blue line? The slope. I'm going to use the slope. Walk me through it. How am I going to, from this point, how am I going to find another one? We are going to use the slope. You're right about that. I know the slope is 1/2. What does the slope tell me? I'm going up by how many? I go up by 1 because I know my slope is a height to base ratio. The number on top is my height, so I go up 1 and I go to the side to left or right? Right. Plot your point. Brinsley. When I say what is the solution to our system, what am I asking you in regards to these two lines right here? I say what is the solution? I'm asking you where they intersect, right? So what is their solution? What did you find this solution point to be? Perfect. 3, -4. I love that you said it. Just the way you said it is a great habit to be in. Naming it as a coordinate. 3, -4. Thumbs up. Did we get 3, -4? Did your graph show 3, -4? Yes. How How many systems do you see on the back of the worksheet? 4 systems. Okay. How many equations are inside of each system? 2. Each system has 2 equations. So, on your coordinate plane, each coordinate plane should have how many lines? 2 lines. The first step you need to do is draw those 2 lines, graph them. That's what y'all are working on now. Okay, draw that line. Well, how can we check it if they are correct? First of all, I want you to put the names right here. What is this location? Put it right here. What is the x value? What is the y value? And then next, we have a great question. How can I check? Substitute. Yes. 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 Check.
Okay, this is really easy. So the only thing you use is just a single machine.
Hi, sir. You're doing amazing.
Yeah, it's really easy. So I agree. Let's start at the lesson system. And you gotta go.
Tell me, where do those 2 lines intersect? Your, let's see what.
Oh wait, hold on. I did it wrong.
Perfect. You gotta do it on this one. This is the first thing you grab. The y-intercept. Luis Rodriguez. What is the intersection point? I don't know where that is, but the good thing is a coordinate plane gives us all these points. I can exactly locate it if it's given to us as x comma y. Good. So I need to make sure my x value is the first number. Edwin? Fabulous. -2, comma 3. All right, I want you to flip to the exit ticket on page 19. I want you to work on that independently and quietly. Students were able to graph a system of equations and correctly identify the point of intersection as the solution. Evidence of mastery was demonstrated through student work, verbal explanations during partner discussions, and accurate responses on exit tickets. Students were also able to explain why the intersection represents the solution, indicating a conceptual understanding rather than a procedural memorization. If I were to teach the lesson again, I would incorporate an additional visual or real world context to introduce systems. While students demonstrated a strong understanding, a contextual example could further help my EL learners and reinforce the relevance of systems beyond the classroom. In future lessons, students transition to solving systems algebraically, such as through substitution, building on conceptual foundations established through graphing. With a diverse group of learners, instruction was intentionally structured to support all students through clear modeling, guided questioning, collaborative learning, and opportunities for mathematical discourse. Student collaboration played a significant role in this lesson, and peer-to-peer discussions helped reinforce understanding and promote confidence in problem solving. I hope you enjoyed.